Okay, this is a video review of the practice exam for problems number 11 and 12. Okay, so in problem 11, you're given some node voltages, and if you recall what we talked about in class is that if we know the node voltages, everything else in the circuit should be easy to solve. All right, and that's true here as well. All right, so I'm given that VA is 4.2 and I know that VB is 14.5, and I want to find a couple of things. I want to find the power used by the 6 ohm resistor, and then in part B it's the voltage across the 2 amp ideal current source. Let's make it a little harder even. Instead of voltage, let's look at power, because you have to have voltage to get to power. So we're going to find the power associated with the 2 amp ideal current source. Right? So, as I mentioned, if I give you node voltages, it's an easy problem. So let's take a look. All right, so if I want to know the power for the 6 ohm resistor, I got a couple of choices on equations. I can do V times I, or I can do V squared over R, or I squared times R. All right, so one of those equations will work. All of those equations will work. So let's choose the voltage one. So V 6 ohms, what's the voltage across the 6 ohm resistor? I can square that, divide by R, and I will get the power. All right, so I do the dot thing like I did in class. Here's the reference, so that's at 0 volts. So if you follow up this way, that's at 0 volts. This would be at 10 volts. Okay, so now I can get the plus and the minus and get the voltage across the 6 ohm resistor. That would simply be 10 minus 4.2, because that's VA, squared, divided by 6, plug that into the calculator, I get 5.6 watts. And because it's power, and because it's a resistor, it's used. Resistors always use power. So if I ask you for power, you need to tell me whether it's used or supplied. Okay. Now in part B, we're going to find the power associated with the 2 amp ideal current source. The problem asks for the voltage, but you got to get the voltage to find the power, so it's a little more complicated problem if I change it like this. Okay, so let's do the power of the 2 amp source. That's the voltage across the 2 amp source times the current of the 2 amp source. Since it's a source, let's make this the active sign convention. Okay, so the active sign convention would mean that if we're trying to find the voltage across the 2 amp source, this would be plus and this would be minus. Okay, because now voltage is in the direction of a current, the current flows in the direction of a voltage rise. That's the active sign convention. Okay, so the voltage across the 2 amp source then would be VB, because that's on the plus side, minus VA, which is on the minus side. Okay, and then we multiply by the current to get the power, and when we plug in these numbers, we get 20.6 watts supplied. I know it's supplied because I used the active sign convention to get this voltage, and it came out to be a positive number, therefore it's supplied. Okay, so that takes care of problem number 11. Let's now move on to problem 12. In problem 12, you're given this circuit. It's just a simple series circuit. You don't know what the elements are in the boxes, but you know the voltage across a couple of them, and you know the current through them. All right, so can you tell me the power associated with each element? All right. So the first thing we need to do is let's find the voltage across B, and that way we'll have the current and voltage across all the elements. All right, we've got everything but B, so let's do that. So what we do is Kirchhoff's voltage law. All right, so we're going to do rises on one side and drops on the other side of the equation. Okay, so if I start right here and I move in a circle like this, if I move across that loop, I would have a drop of VB All right, then I have a drop of 15, and then as I keep moving, I have a rise of 40. Okay, so I can solve that, and I get VB is 25 volts. All right, so now we have everything. We just have to identify the sign convention, plug in the numbers, and we get the answers. Okay, so element A. So I have 2 amps going this way. I got that from here, it just follows that around. So this is the active sign convention because the current's moving up in the direction of a rise. So it'd be 2 amps times 40 volts, which is 80 watts. And it would be supplied because this is active. Positive number, and it's active. All right, now let's move to part B, or element B. For element B, we've already solved for VB. We know that's 25 volts, and the current is 2. And then we get 50 watts, so it's just a matter of interpreting that with the sign convention. So I see here that the current moves in the direction of a drop. So this is the passive sign convention. I get a positive number. That means this is used. Power is used. Okay, and finally, same thing for C. 15 volts times 2. Current's moving in the direction of a drop. So this is consuming power. V times I, 30 watts used. All right, so that's the review for problems 11 and 12 from the practice exam.